In this installment, I was going to talk today about the can on finger demonstration that I did also at Christmas. I will do it first to show you what it is. So, in this case, we take a can of beans. Whoops, let me put it with the label up front. It's the kidney beans. And take the full can. You can see it's closed at both sides. Move slightly. Put your finger on a board like this, that's on the edge of the table, and whack it with the can like this. This is quite effective. It doesn't hurt at all. You can see we've bent the tin on one side. I only ever get it to bend on one side. Looking closer at the tin, we can see what's happened. It's bent over. Hang on, let me get the background. You can see that it's bent in, and that my finger would fit in that hole. If we look very closely at the board, we can't see it. Now, looking very closely at the board, there are two little dents. In the original Scum School episode, they say basically tin is just rubbish, it's not very strong. If we took the top and bottom end off the tin and took a really big one like a catering supplies tin, they come in huge sizes, and punched it with our fist, we would discover the steel of such a tin is not very strong. So that is kind of true, but there are some other things at work here too. Firstly, this type of tin, you can see what we've done to it. We've distorted it slightly into the shape of an oval, which is wider at the sides but narrower at the top and bottom, so it's decreased in volume ever so slightly. That volume has to come from somewhere. If the can was completely filled up with liquid, it would crush my finger. But it's not completely full of liquid because of how these are made. They're made with a bubble of vacuum inside, which I can crush and make a small dent in the can. I can't actually compress it much more, so if I push this side of the tin, the other side bends back out a little bit. There is somewhere for the volume to go. There's a bit of vacuum. The other factor is that I'm hitting it on the middle and not at the end of the can, where it's strengthened by the disc, the metal disc in the end. If I hit myself on the end of the can, if I hit myself on the finger with the end of the can, I will break my finger. The third part, I think it's third, the other part is that when I hit onto my finger, I only have to distort the can by a little bit, and the ends hit a piece of wood underneath, which is why I'm using a piece of wood, because they put two small dents in the end in the wood. But the ends of the cans are quite big, so they're not going to make a big hole in the table and crush my finger again. So most of the energy that I put into whacking the can down goes actually over the ends into the table, and very little of it ends up in my finger. As long as my finger has a certain size compared to the size of the can, I don't run out of space in the can, run out of volume that I can crush before I crush my finger or before the ends of the can hit the table. If I took a different size can or a different size finger, it wouldn't be the same. If we look at the can that I've got, you will notice, looking up close, where is it? You'll notice on the top there's a blue line where I marked it. That's because on these cans, they're made out of a sheet of steel that's bent into a circle and folded over to make the ring with a sealing material in between. That makes a line that's way thicker than the rest of the can, and it's a good idea not to hit yourself with that. It's also quite advantageous not to have it on the top. And therefore, I drew a line on my can where it is, and you can see it's not aligned with the tab. It's not aligned with anything obviously on the bottom. So the other thing that I wanted to avoid forgetting was there are another type of cans that you could try to hit, or that one could try to hit oneself with, which would be drinks cans. They also contain a bubble of gas in well, obviously the top that floats up to the top because it's a liquid, but that is a bubble of gas that's under high pressure. The walls of the can are way weaker, and so the effect is really not very strong, and it's much more likely to hurt you. Because on the one hand, we know, your audience will know, that squeezing an empty can of beans requires a little bit of force, but they know that squeezing an empty, what do you call them in America, soda can, an empty fizzy drinks can, requires pretty much no force. They're made out of aluminium, they're very thin. The only problem is that they're nearly full, and the only gap in there is full of high pressure gas, and if you shake it while you're messing around and swinging it around to hit yourself with, it will be also warm and under more pressure, so when you hit yourself with it, there's nowhere for the volume to go. It has to squeeze against up to 6 bar of gas pressure, possibly or potentially inside a can it's slightly more. That is very difficult, and so you're more likely to hurt yourself. Also, you see the size of the can, the diameter of the can is way smaller, it's significantly smaller for drinks cans, and that makes it also more likely to hurt you because there's less space for the distortion to go to. So it can't distort so much before it's hurt you.